Good. So again, we're going to cover 11.1, goodness of fit, and then we're going to span that into 11.2, test for independence, and the last 13 minutes we'll spend on ANOVA. Due today, you have My Open Math 10.2 due today. That is, making predictions based upon your data. And remember, if you did not reject H naught, that means you do not have a line. So you should not use a regression line to predict X from Y or vice versa. If you did not reject H naught, instead, your best guess for Y is
Y bar.
Y bar. The average Y, your best guess for X is X bar. Yep, the average X. If you did reject H naught, then you do have a line, and then you should use that line, the regression line, Y equals A plus BX, from your linear regression t-test to predict. All right. Let's see what else. The next week you'll have 11.2, 11.1, 11.2 due, and then Thursday, May 28th, you'll have 11.3 due. Also on that day, I'll be meeting here, and I think I'm going to go ahead and do a review session for you folks anyways. And that will be from 4 to 5:30. May 23 from 4 to 5:30. And we'll see if we can talk about it later. If folks are interested in coming or not, because if you're not, if you want to come to one of the other ones, then I'm not going to do it. I mean, there's a reason to hang out, and so we'll kind of see where people feel and confirm that before. Your final is going to be on May 25th, and you said you folks decided that you were good doing it at 4 o'clock. Yes. Okay, so we'll go ahead and proceed with that. Here's the study guide for the final. I want you to take a picture of this. So these particular problems from the previous study guides are the ones that make up the study guide for the final. Obviously, exam 4 is rolled into that exam, so you need to study all of exam 4 study guide, which is in the back of the room. Yeah?
Did you say we don't have class next week? Is that what
We do have class next week.
we do?
Yeah.
What day do we not have class?
May 23rd, we don't have class.
Oh, okay, just okay.
Yeah. So next week is the last week of class.
Got it.
Yeah. Goodness of test fit. So that's what we're working on, the chi-squared. Again, that's called chi-squared. Testing that some observed frequency equals some expected frequency. Typically, it's going to be H naught is, why am I reading this? Let's get Chris, go ahead and read the H naught and H1.
The chi-squared statistic can be used to see whether frequency distribution fits a specific pattern. This is referred to as the chi-square goodness of fit test, which tests the claim that an observed frequency distribution fits the unexpected frequency distribution. H naught is your observed proportions. Fit are what you expect. What actually occurs equals what expected, and H1 is your observed proportions do not fit what you expect. What occurs is not what you expected.
Right. Good. So again, H naught is always, is always equals. So you could shorten it up and put O sub I equals E sub I, in which case H1 would be O sub I is not equal to E sub I. Chapter 10 and 11 are always going to be equal and not equal to. All right. The observed frequencies are always going to be given to you. Those are the ones from the sample. So we have to give you those. They're always going to be whole numbers because you can never observe 2.5 children. All right, it's always going to be a whole number. The expected frequencies can be decimals, and those are calculated, always calculated by you. You have to calculate those. Typically, you'll multiply the percentage by the total, or you'll take the total and divide it equally amongst the categories if they're all equally likely. This is the formula, right? Chi-squared is equal to the sum of, for every category, you take the observed value, subtract the expected value, square that amount, and divide by the expected. and then you add them all up. So because of that, the more categories you have, the more things you're going to add, because you're adding one of these for each category. So the bigger your category is, the larger that chi-squared should become, which is why the degrees of freedom is based upon the number of categories, minus 1. Because, again, it has to allow for the larger degrees of freedom, the larger chi-squared should be able to be before it becomes unusual. So that's how you find the degrees of freedom. It's the number of categories minus 1. Last class we talked about me having you folks calculate write down a couple of those. I'm not going to do that. You don't have to write those down. Just do the test. I think that'll be fine. All right, so how do you do the test? You put your observed values into L1. So your O's are in L1. Expected values into L2. Your expected values are at L2. Find your degrees of freedom. Again, number of categories minus 1. And then you're going to use the GOF test. So you'll do stat test, GOF test of L1, comma, L2, comma, your degrees of freedom. And that will give you your chi-squared and your p-value. Here's a summary of that. Right? H0 frequency is the same. The only thing that changes are step 1 and step 3. You can also just write this for H0 and this for H1. But steps 2, 4, and 5 are exactly the same as always. Okay, so here is your quiz. Let's start with Odessa, give me step 1.
H0 is O sub I equals E sub I, and H1 is O sub I does not equal E sub I.
Which one's the claim?
H0.
What's test the claim that what? So everyone with your neighbors, take 30 seconds and try to figure out what do you think the claim is. The claim is that the outcomes are not equally likely. Is that H0 or H1? All right, so is my claim H1 or H0?
H1.
H1. Right, not equally likely, that's the claim. So we're going to use what word in step 5?
Or
Step 4. What is step 2?
Alpha
Alpha. Alpha is what?
0.025.
Great. Step 3. All right, what's my step 3?
What was the thing called?
Chi-squared?
Oh yeah, chi-squared is.
Oh, no, how do I get there?
Oh, we gotta make a table.
Oh yeah, let's make a table. That sounds great. So what's in my table?
The 1, 2, 3, 4, 5, 6, 7 categories.
Yep.
And then the outcome of 1 is 30, 42 is 47, 43, 48.
Hold on, let me get my O's and E's. Okay, so you're saying you had, 1 was 30,
And then
27,
48, 37, 27, 31.
and then what did you get for your expected values?
200 divided by 6.
Yeah, so 200 divided by 6. So you can either leave it as a fraction, 200 divided by 6. Incidentally, if anybody's using the app on the phone, you have to leave it as a fraction, because if you round at all, like if you put in 33.3 or 33.33 even, it will give you an error, because it's not, you're missing that 100th or that 10th or something like that.
Wait, isn't
So-
K 5?
I'm sorry?
Isn't K 5? Not 6.
K is 6. K is the number of categories.
Wasn't it?
By degrees of freedom is 5. So what can I roll on my dice?
6.
It was, or
6. 1, 2, 3, 4, 5.
1, 2, 3, 4, 5, 6. There's 6 categories.
Yeah.
So if I roll 200 times, I expect a sixth of them to be in 1, a sixth of them to be 2, a sixth of them to be 3. So I need to take 200 divided by 6, and I get 33.3. You have to give me a decimal. You cannot write 33. 33 would be wrong. You can write 33.3 or 33.33. Either one is okay. Or you could use the fraction, 200 over 6, that also works. Any one of those. So I'm just going to do 1 decimal. 1 decimal is fine, 2 decimals is great. Either one is, I'm totally happy with either one. Just you cannot put 33. Because that's not close. Okay, good. So then that's our table. Sean, what test do I do now? What do I do next?
The chi goodness and fit test.
Yep, chi-squared GOF test. So, or you can just call it, I'm okay with you calling it GOF test because there's only one GOF test, so that's okay. And then GOF test of what?
L1, L2, and 5.
Yep, our degrees of freedom is 5. DF equals 6 categories minus 1. 5. Great, what did you get for your chi-squared?
I got P equals 0.0823.
PV equals 0.0823.
Yeah.
Okay, and your chi-squared is
9.76.
9.76.
7, sorry.
77?
Yeah.
Okay. I think most people got that. You might be off a little bit from each other, depending on whether you put 2 decimals or 3 decimals, but it should be in the neighborhood of 0.082 and 9.77 or 9.76, something right in that range. Okay. Good. All right. So then step 4. Austin, what's step 4?
Just compare p-value to alphas. In this case, alpha is less than the p-value.
Mm-hmm.
So you fail to reject H naught.
Great. Fail to reject H naught. That's the same thing as not rejecting H naught. Right, because if I fail to call my father back on the phone, that's the same thing as not calling him back on the phone. Those are the same thing. Failing to do something is the same thing as not doing it. Great. So then in step 5, Jason, what's step 5?
Oh, you restate the claim, right? Or not
Yeah,
enough,
so, yeah,
not
what's
enough
that?
evidence
Not enough evidence?
to support the claim that the outcomes are not equally alike or equally likely.
Right. Not enough evidence to support the claim. Evidence. And my claim was H1. That, what did you say? Outcomes not equally likely?
Yeah.
Yeah, perfect. So again, usually H naught is my claim for chapter 10 and 11, but sometimes H1 is my claim. That can happen. And don't forget your expected values absolutely can have decimals in them. And if they do, you should give me at least 1 decimal. 3 sig figs. Okay. Does anyone see why 33.3 is 3 sig figs?
Yeah. 3.
Yeah. There's the first 3 is the first sig fig. First 1, 2, 3. Good. So that's 3 sig figs. Okay, great. So everyone, go back to our notes and do the type of shopping bags problem. So yes, definitely again, please note that they're given in one order, right? It's given to you as reusable, then plastic, then paper, but then on the observed, they give it to you in a different order. They give you paper, then plastic, and then you have to figure out the reusable. So the homework will have a question like that, may have a question like that also, where the observeds and the expecteds are not given it in the same order. You have to make sure that you line them up. And in previous semesters, I had a student who spent 2 hours just trying to figure out what she was doing wrong, and just they were in the wrong order. So make sure that you get the plastic with the plastic, paper with the paper, reusable with the reusable. And then the second comment was the claim. The question is, does this differ? Right, so the question is your claim. Same sort of thing. All right, let's make sure we're all on the same page with the table. So what are the options? They could have reusable,
All plastic and paper.
and again, we have our observed and we have our expected. So what did we observe? We observed 28 paper, 120 plastic, and the rest were reusable. I have to take 300 and subtract,
140.
yep, 120 minus 28, and I get 152. That's how I get my reusable. My expected I have to calculate. So it's 60%, 0.60 times what? 60% of
300.
300, it's 180. 32% of 300, 96. And 8%, remember 8% is 8 cents, 0.08, not 0.8, otherwise you're going to get way too much. 24. So everybody should be on board with that part. Good. All right, so then where did I leave off? Shaylee, what's my H1?
H1 is, how to say it? I don't remember how to say
Oh,
it.
so what's my H0? Sorry,
Oh,
what's step
H1.
one? Step one, what's step one?
The, how do you say the O thing again?
O, and then O subscript I. So subscript I, you can just call it sub.
Okay,
I?
so O sub I equals E sub I.
Yeah, E subscript I.
Okay.
E subscript I or sub I. Mm-hmm.
And then H1 is O subscript I does not equal E subscript I.
Which one's the claim?
I put H1 as the claim,
Yeah, differs, so that's H1.
which is support.
Support. Great. Sean, what's my step 2?
Alpha equals 0.01.
Good. Jason, have you gone already? I've asked you. Yeah, I did have. Connor, what's step 3?
You're calculating chi, so you do 28 minus 24.
Oh, you have to do that.
Don't-
I'm not making you guys do that anymore. You can just go straight to the.
Okay, in that
Do the-
case, chi squared GOF test, L1, which is 28, 120, 152, and then L2, 24, 96, 180, and then, what is it, it's 3. And I got
You
11.
did 3, you have an error. So this is list 1, that's list 2.
Yeah,
What's my degrees of freedom?
2?
Yeah,
I'm getting confused with that.
so it's number of categories minus 1.
Thought we didn't do that for the last time. I'm getting tripped up on that.
Yeah. It's number of categories minus 1. If you want, you can just refer to your notes. It should be in your notes.
The K is the K.
Is it not in your notes?
Yeah.
There's K and the end, which is nice.
So you're always
The
putting,
K is the comment now.
you always put a degrees of freedom in the calculator.
Yeah. But you
I'm gonna get it right.
Oh, it's not in, is it not in your notes?
It was, I just got tripped up on it.
It's actually not in it. I don't see it in the notes. I'll read this out. So y'all should write it in your notes. DF equals number of categories minus 1. Okay. So L1, L2, and 2. So then,
Should I do 2?
oh, sorry, yes, 2. Great. So Odessa, while you're there, give me the chi-squared and give me the p-value.
My chi-squared was 11.02, and then my p-value was 0.0040.
Great. Okay. Maria, what do I do next?
PV is less than alpha.
Mm-hmm. So then what?
We reject H naught.
And I feel like, Austin, did I not call you yet?
Oh, I think you have, but you want me to do step 5?
I feel like I've called on everybody. Yeah, do step 5, please.
So in this case, there's enough evidence to support claim that the magazine survey differs from a random sample.
Mm-hmm. I'd say just from sample is okay, too. Your sample should be random sample, so you just put samples, that'd be okay. Alright. Everybody feeling solid on 11.1? Perfect. Now we're going to move on to 11.2, which is just expanding on 11.1 a little bit. It's similar, but it's different at the same time. We have two things. Just go to reader. Shady, go ahead and read.
A test of independence tests the null hypothesis that in a contingency table, the row and column variables are independent.
That's homogeneity.
Homogeneity.
Like homogeneous, only instead of homogeneous, it's homogeneity.
Homogeneity of proportions test is used when samples are selected from several different populations to see whether the proportions of each characteristic are the same between populations. Again, to be clear, we are not talking about cause and effect, merely association, just like correlation.
Great, thank you. So we have these things called contingency tables. They are two-way frequency tables. So we have two variables. My data is categorical. So the first bit along my columns is going to be the answers to the first variable, possible answers to that one. Along the rows, my second variable will have, each row will be a different answer to the second variable. So we'll have labels here and labels there, which represent the possible answers to these two variables. You have to have at least two rows and two columns. So notice you have at least two possible answers for each variable. You can't just be like, you know, are you human, or there's no or, right? You have to have a second option. So, are you a cat or a dog? That works. Here's an example. All right, so what two things do we know? There are two variables. What two things do we know about each patient? There's two things we know. What two questions was every patient asked? Take 30 seconds with your neighbors and find that. Find those two variables.